Deep beneath the mountains of Switzerland, in the sterile corridors of CERN's metrology laboratory, physicist Andreas Bauch stands before the most precise timekeeper ever created by human civilization. The optical lattice clock before him measures time with such extraordinary accuracy that it would lose less than 1 second over the entire 14 billion year history of the universe. Yet as Bauch stares at the readout displaying time to 18 decimal places, he confronts a paradox that has haunted physics for over a century. The more precisely we measure time, the more mysterious it becomes. This clock, accurate to 1 part in 10 to the 18th power, reveals temporal effects so subtle that they challenge our most fundamental assumptions about reality. It can detect the time dilation caused by lifting it just 2 centimeters higher in Earth's gravitational field. It registers the infinitesimal changes in the flow of time caused by the Moon's gravitational pull. Most unsettling of all, it demonstrates that there is no universal now, that the very moment you're experiencing as you read these words exists differently for every observer in the universe. The implications are staggering. If time flows differently for every observer, if there is no universal present moment that connects all of reality, then our most basic experience of existence, the sensation of moving from past through present into future, may be nothing more than a persistent illusion created by the limitations of human consciousness. This possibility was first glimpsed by Albert Einstein in 1905, when his special theory of relativity revealed that time is not the absolute universal constant that Newton had assumed, but a flexible dimension that stretches and contracts based on motion and gravity. Einstein's equations showed that time slows down for objects travelling at high speeds, speeds up in weaker gravitational fields, and can even stop entirely at the event horizon of a black hole. But Einstein's most radical insight came not from his mathematical equations, but from a simple thought experiment. He imagined what the universe would look like from the perspective of a photon of light travelling across space. Since photons always travel at the speed of light, time dilation effects cause time to stop entirely from their perspective. For a photon, the entire journey from a distant star to your eye happens in 0 time. The photon experiences its emission and absorption as simultaneous events, regardless of whether it travels for seconds or billions of years. This realization led Einstein to a profound conclusion. From the universe's own perspective, all events throughout cosmic history exist simultaneously in what physicists call the block universe, or eternal present. Past, present, and future are not successive moments in time, but different regions of a 4-dimensional space-time continuum that exists all at once, like different locations in a vast landscape. Hermann Minkowski, Einstein's former mathematics professor, captured this revolutionary insight in 1908 with words that still send shivers down the spines of physicists today. Henceforth space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. The block universe theory suggests that your birth, your current experience of reading these words, and your eventual death all exist simultaneously in the 4-dimensional structure of space-time. The flow of time that seems so fundamental to human experience, the sensation that the present moment is somehow special, that the past is fixed while the future remains open, may be nothing more than a trick of consciousness, like the way a movie creates the illusion of motion from a sequence of static frames. Modern physics has accumulated overwhelming evidence supporting this timeless view of reality. Particle accelerators routinely demonstrate time dilation effects predicted by relativity. GPS satellites must constantly adjust their clocks to account for the different flow of time in Earth's gravitational field. Astronomical observations reveal gravitational lensing effects that bend not just space, but time itself around massive objects like galaxy clusters. But perhaps the most compelling evidence comes from quantum mechanics, where the fundamental equations that describe reality contain no reference to time as we experience it. The Schrödinger equation, which governs the behavior of quantum systems, treats time as merely a parameter, like temperature or pressure, rather than as a fundamental aspect of reality. Quantum states exist in superposition until measured, suggesting that the definite properties we associate with physical objects may be created by the act of observation rather than existing independently in time. Carlo Rovelli, one of the founders of loop quantum gravity theory, has spent decades investigating what happens to time at the most fundamental levels of reality. His research suggests that time emerges from more basic, timeless processes in the same way that temperature emerges from the motion of individual molecules. Just as temperature has no meaning for a single particle, but becomes meaningful for collections of many particles, time may have no meaning at the quantum level but emerge as a statistical property of complex systems. This emergence theory of time explains why our experience of temporal flow seems so convincing while being fundamentally illusory. Our brains, which evolved to track changes and predict future events for survival purposes, create the experience of flowing time by comparing different states of complex systems. But the flow exists only in our neural processing, not in the external world. The illusion becomes apparent when we consider what neuroscience has revealed about temporal perception. The human brain does not passively receive temporal information from the external world, but actively constructs the experience of time through complex neural processes that integrate sensory input, memory, and prediction. Different brain regions process different aspects of temporal experience, the ticking of seconds, the flow of minutes, the passage of hours, and integrate them into the unified experience of flowing time. But this integration can be disrupted. Patients with damage to specific brain regions can lose the ability to perceive temporal sequence while retaining all other cognitive functions. Under the influence of psychedelic compounds, people report experiencing past, present, and future simultaneously, or perceiving events in non-linear temporal sequences that nonetheless feel perfectly coherent. Meditation practitioners describe accessing states of consciousness where time seems to stop entirely, allowing them to experience what they call eternal presence. These altered states of consciousness may provide glimpses of reality as it actually exists, timelessly. If time is indeed a construction of normal waking consciousness, rather than a fundamental feature of reality, then these non-ordinary states may offer more accurate perceptions of the timeless block universe described by physics. The possibility that time is illusory has profound implications that extend far beyond abstract physics. If past, present, and future all exist simultaneously, what happens to free will? Are our choices predetermined if our future actions already exist in the block universe? If death is simply a boundary in space-time rather than an ending in time, what does personal survival mean? If causality operates in a timeless reality, how do cause and effect actually work? These questions probe the deepest foundations of human meaning and identity. We define ourselves through our memories of the past and our plans for the future. We find purpose in the belief that our actions today can influence tomorrow's outcomes. We fear death because we imagine it as the cessation of our existence in time. If time itself is illusory, then everything we think we know about identity, purpose, mortality, and meaning must be reconsidered. The ancient philosophical question, what is time, may have been asking the wrong thing. The real question may be, why do we experience time? If reality is fundamentally timeless, then the mystery is not how time works, but how conscious beings like ourselves generate the persistent illusion that time flows at all. Some physicists suggest that consciousness itself may be the mechanism that creates temporal experience from timeless reality. Just as a film projector creates the illusion of motion by displaying static frames in sequence, consciousness may create the illusion of time by processing timeless information in a particular way. The now that seems so immediate and real may be nothing more than a moving spotlight of awareness, illuminating different regions of an unchanging four-dimensional landscape. But if consciousness creates time rather than existing within it, then the nature of consciousness itself must be far stranger than we have imagined. Instead of being produced by physical processes unfolding in time, consciousness may be the fundamental feature of reality that gives rise to the experience of time, space, and physical existence itself. This possibility transforms our understanding of what it means to be human. Rather than being temporary patterns of matter and energy that briefly exist before dissolving back into unconsciousness, we may be eternal features of a timeless reality that temporarily experience ourselves as existing within time. Death may not be an ending, but a transition from temporal to timeless modes of existence. Life may not be a brief interval between birth and death, but an eternal present that we experience through the filter of time-bound consciousness. The precision atomic clocks at CERN that can measure time to unprecedented accuracy may be revealing the ultimate truth about time itself. that it is measurement, not time, that is real. The numbers on the clock display exist, the atomic oscillations that generate them exist, the electromagnetic fields that transmit the signals exist. But the time they purport to measure may be nothing more than a useful fiction that conscious beings impose on a fundamentally timeless reality. As Andreas Bauch stares at his impossibly precise timekeeper, he may be looking at the most sophisticated illusion-generating device ever created, a machine that creates the appearance of temporal flow from the eternal present of quantum mechanical reality. The clock's precision does not reveal time's nature, but rather the depth of time's illusory character. But to understand how this illusion could be so convincing, we must trace the historical development of humanity's discovery that time is not what it seems. A journey that began with Einstein's radical insights and continues with today's cutting-edge physics research that challenges everything we thought we knew about the fundamental nature of reality. In the summer of 1905, in a cramped apartment above a cobbler's shop in Bern, Switzerland, a 26-year-old patent clerk named Albert Einstein stares at equations that will destroy humanity's conception of time forever. Working in isolation from the academic physics community, supporting his family on a modest government salary while pursuing theoretical physics in his spare time, Einstein has stumbled upon a truth so radical that it challenges the fundamental assumptions about reality that have guided human thought for millennia. The problem that obsesses Einstein seems almost trivial. Why does light always travel at the same speed regardless of the motion of its source or observer? Classical physics, built on Newton's absolute conception of time and space, predicts that light from a moving source should travel faster in the direction of motion, just as a ball thrown from a moving train travels faster than one thrown from a stationary platform. But experiments consistently show that light maintains the same speed, approximately 300 million meters per second, under all circumstances. Einstein's genius lies in recognizing that this experimental fact requires abandoning one of humanity's most basic intuitions, that time flows uniformly throughout the universe, ticking away at the same rate for all observers regardless of their motion or location. If the speed of light is truly constant, then time itself must be variable, stretching and contracting to ensure that light always covers the same distance in what each observer measures as the same duration. The mathematics Einstein develops to describe this flexibility of time are deceptively simple, involving nothing more advanced than high school algebra. But their implications are revolutionary. As objects approach the speed of light, time slows down from the perspective of stationary observers. A twin travelling to a distant star at 99% of light speed would age only 7 years during a journey that takes 50 years, as measured by clocks on Earth. This time dilation effect is not a mere theoretical curiosity, but a measurable reality confirmed by countless experiments. Atomic clocks flown on high-speed aircraft run slower than identical clocks left on the ground, exactly as Einstein's equations predict. Particles created in cosmic ray collisions high in Earth's atmosphere should decay long before reaching the surface, yet they arrive intact because their high-speed motion slows their internal clocks to such a degree that they experience insufficient time to decay. But Einstein's special theory of relativity reveals something even more disturbing than time's flexibility: the complete relativity of simultaneity. Events that are simultaneous for one observer occur at different times for observers moving at different velocities. There is no universal now that connects all points in the universe. The present moment that seems so immediate and absolute is actually different for every observer. This discovery strikes at the heart of our intuitive understanding of existence. We imagine that somewhere in the universe, events are happening right now simultaneously with our own experience. We picture distant galaxies, alien civilizations, and cosmic events as existing in the same present moment that we inhabit. But Einstein's equations reveal that this shared present is an illusion. Your now is not the same as the now experienced by someone walking past you on the street, let alone by hypothetical observers in distant galaxies. The implications become even more radical when Einstein extends his theory to include gravity in his general theory of relativity, published in 1915. Gravity, Einstein realizes, is not a force pulling objects together, but the curvature of space-time itself. massive objects like stars and planets bend the fabric of space-time, creating the effects we interpret as gravitational attraction. This geometric understanding of gravity reveals that time flows differently in gravitational fields of different strengths. Clocks run slower in stronger gravitational fields and faster in weaker ones. A clock at sea level runs measurably slower than one at the top of a mountain because it experiences Earth's gravity more intensely. The difference is tiny, mere nanoseconds per day. But modern atomic clocks are precise enough to detect it easily. The Global Positioning System provides daily confirmation of gravitational time dilation effects. GPS satellites orbit Earth at altitudes where they experience weaker gravitational fields than receivers on the surface, causing their clocks to run approximately 38 microseconds faster per day than Earth-based clocks. Without constant correction for these relativistic effects, GPS navigation would become inaccurate by several kilometers within hours. But the most profound implications of Einstein's theories emerge when we consider their effect on the concept of universal time. If time flows differently for every observer depending on their motion and gravitational environment, and if simultaneity is relative rather than absolute, then the entire framework of past, present and future that organizes human experience may be fundamentally mistaken. Hermann Minkowski, Einstein's former mathematics professor at the Swiss Federal Polytechnic, provided the mathematical framework that makes this revolutionary perspective precise. In 1908, Minkowski showed that special relativity is most naturally understood by treating time as the fourth dimension of a unified space-time continuum. Events in the universe are not located in space at particular moments in time, but at specific coordinates in four-dimensional space-time. Minkowski's space-time geometry reveals the block universe in mathematical detail. Just as we can visualize a three-dimensional object like a loaf of bread as a collection of two-dimensional slices, we can visualize the four-dimensional history of the universe as a collection of three-dimensional spatial slices representing different moments in time. But unlike the arbitrary nature of how we slice bread, the way we slice space-time into temporal moments depends entirely on the observer's motion and gravitational environment. Different observers moving at different velocities will slice the same four-dimensional space-time into different sequences of three-dimensional presence. Events that one observer experiences as happening in sequence may be experienced by another observer as happening simultaneously or even in reverse order. The past, present and future are not absolute features of reality, but depend entirely on the observer's reference frame. This revelation transforms our understanding of existence itself. If all moments in time exist simultaneously within the four-dimensional block of space-time, then the dinosaurs, Napoleon, your childhood, and your death are all equally real and eternally present. The flow of time that seems to carry us from past to future is not a feature of reality, but a psychological artifact of how consciousness processes the timeless information contained in space-time. John Wheeler, the American physicist who coined the term black hole and mentored generations of relativity researchers, spent decades exploring the implications of this timeless view of reality. Wheeler argued that the fundamental equations of physics, from Einstein's field equations to the Schrödinger equation of quantum mechanics, describe relationships between events rather than evolution through time. Wheeler's most radical insight came from his work on quantum gravity, where he attempted to understand how Einstein's geometric theory of spacetime might emerge from quantum mechanics. The Wheeler-DeWitt equation, which Wheeler developed with physicist Bryce DeWitt, describes the quantum state of the entire universe without any reference to time whatsoever. At the most fundamental level of reality, Wheeler concluded, time simply does not exist. This timeless formulation of quantum gravity suggests that time emerges from more basic, atemporal processes in the same way that temperature emerges from molecular motion or pressure emerges from particle collisions. Individual molecules do not have temperature, but collections of molecules moving at different speeds create the statistical property we experience as heat. Similarly, individual quantum events may be timeless, but collections of quantum processes may create the statistical property we experience as temporal flow. Carlo Rovelli, working at the Centre de Physique Théorique in Marseille, has developed this emergent view of time into a comprehensive theory called loop quantum gravity. Rovelli's research suggests that at the smallest scales of space and time, the Planck length of approximately 10 to the minus 35 meters, and the Planck time of approximately 10 to the minus 44 seconds. The smooth space-time continuum described by Einstein's theories breaks down into a discrete granular structure. At these quantum scales, Rovelli argues, time loses its meaning entirely. The quantum geometry of space fluctuates and changes, but these changes do not occur in time, because time itself has not yet emerged from the more fundamental quantum processes. Time appears only when we consider large numbers of quantum events and observe statistical regularities in their relationships. This perspective explains why time seems so fundamental to our experience while being absent from the most basic equations of physics. Time is not built into the structure of reality at the deepest level, but emerges as a useful approximation when dealing with complex systems containing large numbers of interacting components. Just as we can usefully talk about the temperature of a gas without considering the motion of every individual molecule, we can usefully talk about temporal evolution without considering the timeless quantum processes that generate the appearance of temporal flow. The emergent nature of time also explains why time's direction, from past to future rather than future to past, is not specified by the fundamental laws of physics. Einstein's equations work equally well whether time runs forward or backward. The Schrödinger equation is time reversible. The basic laws of electromagnetism show no preference for temporal direction. Yet our experience of time has a definite arrow pointing from past to future. We remember the past, but not the future. We see broken glasses spontaneously assemble themselves into whole glasses. We age rather than growing younger. This temporal asymmetry must arise from the initial conditions of the universe, rather than from the fundamental laws of physics themselves. The resolution of this puzzle may lie in the low entropy state of the early universe. At the moment of the Big Bang, the universe began in an extremely ordered low entropy configuration. As the universe evolved, entropy increased according to the second law of thermodynamics, creating the statistical arrow of time that we experience as the direction from past to future. But if time's direction is determined by entropy increase rather than by fundamental physical law, then the arrow of time is not absolute but statistical. In principle, in regions of space-time where entropy happens to decrease, time's arrow could point in the opposite direction. Local reversals of entropy could create pockets of backward time, where events unfold from what we would consider future to past. These insights reveal that Einstein's revolution was even more radical than initially recognized. He did not simply show that time is relative and flexible. He revealed that time as we experience it may not exist at the fundamental level of reality at all. The flowing time that organizes human consciousness and shapes our understanding of existence may be nothing more than an emergent statistical property of complex systems, as far removed from basic reality as the wetness of water is from the quantum fields that constitute hydrogen and oxygen atoms. This recognition transforms every aspect of human self-understanding. If we exist in a timeless block universe, where all moments are equally real and eternal, then death is not the cessation of existence, but merely a boundary in space-time. If free will operates in a reality where future events already exist, then choice and determinism must be understood in entirely new ways. If consciousness creates the experience of temporal flow from timeless reality, then awareness itself may be far stranger and more fundamental than we have ever imagined. But to understand how profoundly quantum mechanics supports and extends Einstein's timeless vision of reality, we must explore how the quantum world operates according to principles that transcend temporal sequence entirely. In the basement laboratories of the University of Vienna, quantum physicist Anton Zeilinger manipulates individual photons of light with laser precision, creating experiments that reveal the most disturbing aspects of reality ever discovered by science. His laboratory, shielded from electromagnetic interference and cooled to temperatures approaching absolute zero, represents humanity's most sophisticated attempt to peer into the fundamental nature of existence. What Zeilinger finds there challenges not just our understanding of time, but our basic assumptions about cause, effect, and the relationship between observation and reality. The quantum world that emerges from Zeilinger's experiments operates according to principles that seem to transcend temporal sequence entirely. When two particles become quantum entangled, their properties mysteriously linked regardless of the distance separating them, changes to one particle appear to instantly affect its partner, even when they are separated by thousands of kilometers. This spooky action at a distance, as Einstein dismissively called it, occurs faster than light could travel between the particles, suggesting that quantum correlations transcend the speed of light barrier that limits all other forms of communication. But the most unsettling aspect of quantum entanglement is not its apparent instantaneousness, but its timeless character. The correlations between entangled particles do not depend on when measurements are made. A measurement performed on one particle today will correlate perfectly with measurements performed on its partner yesterday, tomorrow, or at any other time. The quantum connection exists outside of temporal sequence, linking events that occur at different times as easily as events that occur simultaneously. This timeless nature of quantum correlations becomes even more mysterious when we consider delayed choice experiments, where decisions about how to measure quantum systems are made after the systems have already interacted with measurement apparatus. In these experiments, choices made in the future appear to retroactively determine what happened in the past, as if the temporal sequence of cause and effect operates differently at the quantum level than in our everyday experience. The most famous delayed choice experiment, first proposed by John Wheeler and later implemented by researchers around the world, involves sending individual photons through an interferometer, a device that splits light beams and recombines them to create interference patterns. In classical physics, we would expect each photon to take either one path or the other through the interferometer. But quantum mechanics predicts that individual photons can somehow take both paths simultaneously, interfering with themselves to create the characteristic stripe patterns of wave interference. Wheeler's insight was to delay the decision about whether to observe which path information until after the photons had already passed through the interferometer. If experimenters choose to measure which path each photon took, the interference pattern disappears, suggesting that each photon travelled through only one path. If they choose not to make this measurement, the interference pattern appears, indicating that each photon somehow travelled through both paths simultaneously. The disturbing implication is that the experimenter's future decision about what to measure retroactively determines how the photon behaved in the past. The photon's path through the interferometer is not determined until the measurement choice is made, even if that choice occurs after the photon has already passed through the apparatus. This suggests that quantum events exist in a state of temporal superposition until observed, with their definite properties extending backward and forward in time from the moment of measurement. These temporal anomalies become comprehensible only when we recognize that quantum mechanics describes a fundamentally timeless reality. The mathematical formalism of quantum theory, the wave function that describes quantum systems, evolves according to the Schrödinger equation, but this evolution is perfectly reversible. The equation works equally well whether time runs forward or backward, and it describes relationships between quantum events rather than temporal sequences of cause and effect. Erwin Schrödinger, the Austrian physicist who developed the wave equation that bears his name, was deeply troubled by the implications of his own theory. In 1935, he proposed a thought experiment involving a cat trapped in a box with a quantum-triggered poison mechanism. According to quantum mechanics, until the box is opened and observed, the cat exists in a superposition of being simultaneously alive and dead. Schrödinger intended this thought experiment as a criticism of quantum mechanics, pointing out the absurdity of applying quantum superposition to macroscopic objects. But subsequent research has revealed that Schrödinger's cat illustrates a profound truth about the nature of reality. Quantum superposition may be the fundamental state of all systems, with definite properties emerging only through the process of measurement or observation. The measurement problem, the question of how and when quantum superpositions collapse into definite states, represents one of the deepest mysteries in physics. The mathematical formalism of quantum mechanics describes the evolution of quantum systems with extraordinary precision, predicting the probabilities of different measurement outcomes with accuracy that exceeds any other theory in science. But the theory provides no mechanism for the transition from quantum superposition to classical definiteness. This problem becomes even more acute when we consider that the measurement apparatus itself consists of quantum particles that should also exist in superposition until observed. If the detector used to measure a quantum system is itself in superposition, how can it cause the collapse of the system being measured? This leads to an infinite regress. Each measurement device requires another measurement device to collapse its superposition, with no clear endpoint where definite properties emerge. Hugh Everett III, a graduate student at Princeton University in the 1950s, proposed a radical solution to the measurement problem that eliminates the need for wave function collapse entirely. Everett suggested that quantum superpositions never actually collapse. Instead, when a measurement is made, the universe splits into parallel branches corresponding to each possible measurement outcome. The experimenter also splits, with different versions experiencing each possible result. From this many worlds perspective, Schrödinger's cat is both alive and dead. In different branches of the universal wave function, every quantum measurement creates new branches of reality, leading to an exponentially expanding multiverse containing all possible versions of history. Time becomes not a single flowing river, but an ever-branching tree where every possible sequence of events is equally real. The many worlds interpretation eliminates the measurement problem by making measurement and time emergence properties of conscious observers, rather than fundamental features of reality. Each branch of the universal wave function contains observers who experience a particular sequence of measurement outcomes, creating the illusion of temporal flow and definite properties. But from the perspective of the universal wave function itself, all possibilities exist simultaneously in a timeless quantum superposition. Carlo Rovelli has developed an alternative interpretation of quantum mechanics, called relational quantum mechanics, that also eliminates absolute time while avoiding the exponential multiplication of parallel worlds. In Rovelli's view, quantum systems do not possess definite properties, independent of observation, but only relative to specific observers or measurement contexts. The key insight of relational quantum mechanics is that different observers can maintain contradictory descriptions of the same quantum system without logical inconsistency, as long as their observations are consistent when compared directly. This suggests that time, like other quantum properties, exists only relative to specific observers rather than as an absolute feature of reality. From this relational perspective, the temporal sequence of events depends entirely on the observer's reference frame and interaction history with the systems being observed. Two observers who interact with the same quantum system at different times may assign different temporal orderings to the same events, with both descriptions being equally valid within their respective reference frames. This relational view of time receives support from research into quantum gravity, where physicists attempt to unify quantum mechanics with Einstein's general theory of relativity. The resulting theories consistently suggest that time is not fundamental, but emerges from more basic atemporal quantum processes. Loop quantum gravity, developed by Carlo Rovelli, Lee Smolin, and other researchers, describes space-time as composed of discrete quantum units at the smallest possible scales. These quantum units do not exist in time, but represent the fundamental building blocks from which both space and time emerge through complex quantum interactions. String theory, the alternative approach to quantum gravity that describes particles as vibrating strings in higher dimensional spaces, also suggests that time is emergent rather than fundamental. The mathematical structures that describe string interactions are essentially timeless, with temporal evolution emerging only when we consider how these structures appear to observers embedded within them. The holographic principle, which suggests that all the information in a three-dimensional volume of space can be encoded on its two-dimensional boundary, implies that time may be a kind of holographic projection from a fundamentally timeless substrate. Just as a hologram creates the appearance of three-dimensional depth from two-dimensional information, the passage of time may be created by consciousness projecting temporal structure onto a temporal quantum information. These insights from quantum gravity research converge on a remarkable conclusion. Time as we experience it, as a flowing sequence of moments from past through present to future, does not exist at the most fundamental level of reality. Instead, time emerges as an approximate description useful for describing complex systems, but absent from the basic quantum processes that generate all physical phenomena. This timeless view of quantum reality explains many of the paradoxes that have puzzled physicists since the development of quantum mechanics. Quantum entanglement appears instantaneous because it operates in a timeless realm where the concept of simultaneity is meaningless. Delayed choice experiments seem to allow future events to influence past events, because both past and future events exist simultaneously in timeless quantum superposition. The observer effect, the fact that quantum systems behave differently when observed than when unobserved, may reflect the role of consciousness in creating temporal structure from a temporal quantum information. Conscious observation does not cause quantum wave functions to collapse, but rather selects particular sequences of quantum events to experience as temporal evolution. This suggests that consciousness and time are intimately connected, with awareness serving as the mechanism that generates temporal experience from timeless quantum reality. Different conscious observers may experience different temporal sequences from the same underlying quantum substrate, depending on their particular patterns of interaction with quantum systems. But if consciousness creates time rather than existing within it, then the nature of awareness itself must be fundamentally different from what we have assumed. Consciousness may not be produced by physical processes evolving in time, but may be the timeless substrate that gives rise to the appearance of physical processes and temporal evolution. The implications extend far beyond theoretical physics to touch the deepest questions of human existence. If quantum mechanics reveals that reality is fundamentally timeless, then death may not represent the cessation of existence, but merely a boundary in a temporal quantum information. Personal identity may not depend on continuity through time, but on timeless patterns of quantum correlation. Memory and anticipation may not connect us to past and future events, but may be ways of accessing different regions of timeless quantum reality. But to understand how this timeless quantum reality gives rise to our compelling experience of temporal flow, we must examine the thermodynamic processes that create the arrow of time, the asymmetry that makes past and future feel fundamentally different despite their equal reality in the timeless block universe. In the pristine laboratories of the California Institute of Technology, cosmologist Sean Carroll stares at computer simulations that model the evolution of the entire universe from its first moments to its ultimate fate trillions of years in the future. The equations flowing across his monitors reveal a profound asymmetry that seems to violate everything we have learned about the fundamental timelessness of physical law. While the basic equations of physics work equally well, whether time runs forward or backward, the universe itself shows a clear preference for one temporal direction over another. This directional bias appears most dramatically in the second law of thermodynamics, which states that the entropy of isolated systems always increases over time. Entropy, a measure of disorder or randomness, provides the clearest example of time's arrow in physical law. Hot objects cool down but never spontaneously heat up. Gases expand to fill available space but never spontaneously compress. Complex structures decay into simpler forms but never spontaneously organize themselves into greater complexity. The second law seems to contradict the time-reversible character of fundamental physics. If the basic equations governing matter and energy work equally well in both temporal directions, why does entropy consistently increase rather than decrease? Why do we never observe broken glasses spontaneously reassembling themselves, even though such events would violate no fundamental physical laws? Carroll's research reveals that this temporal asymmetry does not arise from the laws of physics themselves, but from the highly unusual initial conditions of our universe. At the moment of the Big Bang, approximately 13.8 billion years ago, the universe began in an extremely ordered low-entropy state. All matter and energy were concentrated in an infinitesimally small, perfectly smooth region of space-time with virtually no structural complexity or disorder. This initial low-entropy state represents one of the most improbable configurations imaginable. The overwhelming majority of possible arrangements of matter and energy correspond to high-entropy states with maximum disorder and complexity. The probability that the universe would begin in such an ordered condition by random chance is so vanishingly small that it approaches zero for all practical purposes. Yet this improbable beginning explains why we experience time as flowing from past to future rather than future to past. As the universe evolved from its initial low-entropy state, entropy increased according to the second law of thermodynamics, creating the statistical arrow of time that defines our experience of temporal direction. The past is the direction toward lower entropy, the future is the direction toward higher entropy. This thermodynamic arrow of time affects every aspect of our temporal experience. We remember the past because memory formation requires the creation of ordered structures in our brains, a process that increases entropy in our environment while decreasing it locally. We cannot remember the future because future events have not yet created the entropy-increasing traces that register as memories. We age from young to old because biological aging represents the accumulation of entropy in our cells and organs over time. DNA damage, protein degradation, and cellular wear represent increases in molecular disorder that define the aging process. Reversing aging would require decreasing entropy in biological systems, a process that would violate the second law of thermodynamics for isolated systems. But the most profound implication of thermodynamic time asymmetry is that it may be entirely arbitrary. If the universe had begun in a high entropy state and evolved toward lower entropy, we would experience time's arrow pointing in the opposite direction. Events we consider to belong to the future would feel like the past and vice versa. The direction of time's arrow is determined entirely by the initial conditions of the universe rather than by any fundamental temporal asymmetry in physical law. Ludwig Boltzmann, the 19th century Austrian physicist who first understood the statistical nature of entropy, recognized the arbitrary character of time's direction. He proposed that in an eternal universe with random fluctuations, entropy would occasionally decrease in local regions, creating pockets where time's arrow points backward relative to the overall cosmic direction. Boltzmann's insight leads to one of the strangest predictions in physics, the existence of Boltzmann brains. In a universe with random thermal fluctuations, it is more probable for a brain to spontaneously materialize from random particle motions than for an entire complex universe to evolve from low-entropy initial conditions. These randomly assembled brains would have false memories of past experiences and incorrect beliefs about their surroundings, making their subjective experience indistinguishable from that of evolved biological brains. The Boltzmann brain paradox reveals the profound arbitrariness of our temporal experience. If consciousness can arise from random fluctuations as easily as from evolutionary processes, then our memories of the past may be no more reliable than hallucinations. The entire history of the universe that we reconstruct from physical evidence may be nothing more than a false memory implanted in randomly assembled neural structures. Carroll's cosmological research addresses the Boltzmann brain problem by investigating why the universe began in such an improbably low-entropy state. One possibility is that our observable universe is just one region of a much larger multiverse where different regions begin with different entropy levels. We find ourselves in a low-entropy region not because such regions are probable, but because only low-entropy regions can support the complex structures necessary for conscious observation. This anthropic explanation suggests that the arrow of time is observer-selected rather than physically fundamental. Conscious beings can only evolve in regions of the multiverse where entropy increases over time, so all conscious observers necessarily experience temporal asymmetry, even though the underlying physical laws are time-symmetric. But Carroll proposes an even more radical possibility, that the initial low entropy of our universe might be explained by considering the quantum mechanical nature of the Big Bang itself. If the universe began as a quantum fluctuation from a timeless state, then its low entropy beginning might reflect the structure of the quantum vacuum rather than an improbable statistical accident. This quantum cosmological perspective suggests that time's arrow emerges from the quantum mechanical process that created our universe. The apparent flow of time from past to future reflects the way quantum mechanical probability amplitudes evolved from their initial configuration at the Big Bang. Different possible universes with different initial quantum states would experience different arrows of time, or perhaps no temporal asymmetry at all. The research of cosmologist Alan Guth on cosmic inflation provides additional insight into the origin of time's arrow. Guth's theory suggests that the universe underwent a period of exponential expansion during its first fraction of a second, stretching quantum fluctuations to cosmic scales. This inflationary process would have created the large-scale structure and entropy gradients that generate the thermodynamic arrow of time. But inflation itself requires specific initial conditions to produce the low-entropy universe we observe. The inflaton field that drives cosmic expansion must begin in a particular configuration to generate the right amount of expansion and create the density fluctuations that eventually form galaxies and stars. the question of why these initial conditions obtained remains one of the deepest mysteries in cosmology. String theory cosmologist Brian Greene has explored how the thermodynamic arrow of time might emerge from the higher dimensional geometry of string theory. In string theory, our four-dimensional universe may be embedded in a higher dimensional space, where different regions experience different temporal orientations. The arrow of time that we experience might reflect our particular location within this higher dimensional structure. This possibility suggests that time's direction is not even consistent throughout the universe. Different regions of space-time might experience opposite arrows of time, with entropy increasing in one direction in some regions and in the opposite direction in others. The boundary between such regions would represent temporal interfaces where past and future exchange roles. The quantum mechanical foundation of thermodynamics reveals additional complexities in the relationship between entropy and time. At the quantum level, entropy is not simply a measure of disorder, but reflects the amount of information required to specify the complete quantum state of a system. Quantum entanglement can create correlations between distant systems that reduce the total entropy below what would be expected for independent systems. This quantum information perspective on entropy suggests that time's arrow might be more accurately understood as an arrow of information flow rather than an arrow of increasing disorder. The past is the direction from which we receive information about the state of the universe, while the future is the direction toward which we can send information through our actions and decisions. Quantum mechanics allows for the possibility of negative entropy, or negentropy, in systems where quantum correlations reduce the information content below classical expectations. These quantum effects might allow for local reversals of time's arrow in systems where quantum information flow contradicts thermodynamic expectations. The black hole information paradox discovered by Stephen Hawking reveals additional complications in the relationship between entropy and time. Black holes appear to destroy information when they evaporate through Hawking radiation, violating the principle that quantum mechanical evolution should be reversible. The resolution of this paradox may require recognizing that information and time are more fundamentally connected than previously understood. Some physicists propose that information is more fundamental than matter or energy, with time arising from the flow of information through quantum systems. From this perspective, the thermodynamic arrow of time reflects the direction in which quantum information propagates through the universe, creating the statistical regularities we interpret as physical law. The holographic principle in theoretical physics suggests that all the information in a volume of space can be encoded on its boundary, implying that time might be a holographic projection from a fundamentally temporal information structure. The arrow of time would then reflect the particular way that holographic information is decoded by conscious observers embedded within the holographic projection. These insights from quantum information theory and holographic physics suggest that the thermodynamic arrow of time is not as fundamental as it appears. Rather than representing an irreversible increase in disorder, entropy increase may reflect the particular way that conscious observers process quantum information within their local region of the universe. This information-theoretic view of time's arrow explains why temporal asymmetry appears so fundamental to conscious experience while being absent from the basic equations of physics. Consciousness may be an information processing system that necessarily experiences temporal asymmetry because it operates by creating ordered structures, memories, models, predictions, from initially disordered inputs. The subjective experience of time's flow, the sensation that the present moment is moving from past to future, may reflect the computational process by which conscious systems extract ordered information from their environment. This extraction necessarily increases entropy in the environment while decreasing it in the conscious system, creating the local violation of the second law that characterizes all living processes. But if time's arrow is an artifact of information processing rather than a fundamental feature of reality, then different information processing systems might experience different temporal orientations. Hypothetical forms of consciousness that operate according to different information processing principles might experience time flowing backward, sideways, or in multiple directions simultaneously. The recognition that time's arrow emerges from thermodynamic and information processing asymmetries rather than fundamental temporal flow has profound implications for understanding consciousness itself. If the experience of temporal passage is created by the entropy-increasing process of extracting information from the environment, then consciousness and time may be more intimately connected than previously imagined. The flow of time that seems so fundamental to human experience may be nothing more than the subjective shadow cast by the information processing activities of conscious systems operating within a fundamentally timeless block universe. The past and future that structure our experience may be computational constructs rather than objective features of reality. But to understand how consciousness creates the experience of temporal flow from timeless physical processes, we must examine what neuroscience and psychology have revealed about the biological mechanisms that generate our perception of time's passage. In the neuroimaging facilities at Stanford University, neuroscientist David Eagleman watches brain scans of patients whose temporal perception has been shattered by stroke or injury. On the monitors before him, the normally synchronized neural networks that create our unified experience of time showed dramatic disruptions. Some patients can no longer sequence events, experiencing conversations as jumbled collections of words that arrive in random order. Others have lost the ability to estimate duration, unable to distinguish between seconds and hours. Most disturbing of all are patients who report that time has stopped entirely. They experience each moment as an eternal present with no connection to past or future. These cases of temporal brain damage reveal something extraordinary about the nature of time perception. Our experience of flowing time is not a passive reception of temporal information from the external world, but an active construction created by specific neural networks in the brain. When these networks are damaged, the illusion of temporal flow dissolves, leaving patients stranded in fragments of disconnected experience that reveal time's fundamentally constructed character. The neuroscience of temporal perception shows that the brain does not contain a single time center that processes temporal information, but instead uses multiple distributed networks that handle different aspects of temporal experience. The suprachiasmatic nucleus regulates circadian rhythms over 24-hour cycles. The cerebellum processes millisecond-scale timing crucial for motor coordination. The prefrontal cortex integrates temporal information across different timescales to create unified temporal experience. Most remarkably, these temporal processing systems can be selectively disrupted without affecting other cognitive functions. Patient studies reveal individuals who have lost the ability to perceive the sequence of events while retaining perfect memory, language, and reasoning abilities. These patients remember everything that happens to them, but cannot organize their memories in temporal order, experiencing their entire life history as a simultaneous collection of equally present moments. Eagleman's research reveals that the brain's temporal processing systems evolved not to perceive time accurately, but to create useful illusions that enhance survival. The specious present, the roughly 3-second window of experience that feels like now, represents the brain's attempt to bind together sensory information that actually arrives at different times into a coherent perceptual moment. When you see someone speak, the visual information from their lip movements arrives at your brain before the auditory information from their voice due to the different speeds of light and sound. Yet you experience these events as simultaneous because your brain delays the visual information to synchronize it with the slower auditory input. This temporal binding creates the illusion of simultaneous audiovisual experience from physically non-simultaneous events. The brain performs similar temporal manipulations to create the experience of causal sequence. When you decide to move your hand and then see it move, your brain actually begins preparing the movement before you become consciously aware of deciding to move. The sense of conscious intention causing physical action is created by the brain's retrospective attribution of causality to events that were actually initiated by unconscious neural processes. This temporal manipulation becomes even more dramatic during altered states of consciousness. Under the influence of psychedelic compounds like psilocybin or LSD, the brain's temporal binding mechanisms become disrupted, allowing people to experience time in radically non-linear ways. Research subjects report experiencing past, present, and future simultaneously, or perceiving causal relationships running backward from effect to cause. Robin Carhart-Harris, director of the Centre for Psychedelic Research at Imperial College London, has used brain imaging to study how psychedelic compounds affect temporal perception. His research reveals that psychedelics reduce activity in the default mode network, a collection of brain regions active during rest and introspection that appears to be crucial for maintaining normal temporal experience. When the default mode network is suppressed, the brain's normal temporal binding processes break down, allowing consciousness to access what Carhart Harris calls the timeless present, a state of awareness that transcends the ordinary sequence of past, present, and future. In this state, subjects report profound insights into the nature of existence and often describe feeling connected to eternal or cosmic consciousness. These psychedelic-induced alterations in temporal perception may provide glimpses of how consciousness functions when freed from the brain's normal temporal construction processes. The experiences reported during these states, of existing in an eternal now, of accessing information from past and future simultaneously, of understanding reality as fundamentally timeless, closely match the picture of reality emerging from theoretical physics. Long-term meditation practitioners report similar experiences of timeless awareness achieved through contemplative practice rather than chemical intervention. Advanced meditators describe states of consciousness where temporal experience disappears entirely, replaced by pure awareness that exists in an eternal present. These states, achieved through years of training and focused attention, suggest that the brain's temporal construction mechanisms can be voluntarily suspended through mental discipline. Neuroscientist Judson Brewer at Yale University has studied the brains of advanced meditation practitioners using functional magnetic resonance imaging. His research reveals that experienced meditators show reduced activity in the same default mode network regions that are suppressed by psychedelic compounds. This suggests that meditation and psychedelics may access similar brain states associated with non-ordinary temporal experience. The meditation research reveals that temporal experience exists on a spectrum from highly constructed narrative consciousness to pure awareness without temporal content. Ordinary waking consciousness represents one extreme of this spectrum, where complex neural networks create elaborate temporal constructions that organize experience into stories extending from past through present into future. But the other extreme, pure awareness without temporal construction, may represent consciousness in its most fundamental form. From this perspective, the flowing time that characterizes normal human experience is an elaborate cognitive construction layered on top of more basic awareness that is itself timeless. Split brain research provides additional evidence that temporal experience is actively constructed rather than passively received. Patients who have had their corpus callosum severed to treat epilepsy essentially have two independent consciousness systems in their left and right brain hemispheres. Remarkably, these two systems can have different temporal experiences of the same events. The left hemisphere, which contains language processing areas, creates verbal narratives that organize experience in temporal sequences. The right hemisphere, which excels at spatial and holistic processing, appears to experience events more simultaneously and less sequentially. When the connection between hemispheres is severed, patients can literally have two different temporal experiences of the same events occurring in parallel. This split brain research suggests that unified temporal experience depends on communication between different brain regions that process temporal information in different ways. When this communication is disrupted, consciousness fragments into multiple temporal streams that can contradict each other without creating any sense of logical inconsistency. The neuroscience of memory provides additional insights into the constructed nature of temporal experience. Rather than storing past events like a video recording, memory systems actively reconstruct past experiences each time they are retrieved, often incorporating information from the present moment into supposedly historical recollections. This reconstructive character of memory means that our sense of personal history, the temporal narrative that defines individual identity, is constantly being revised and updated based on present circumstances. The past that feels so fixed and definite is actually a fluid construction that changes each time we remember it. Elizabeth Loftus, a cognitive psychologist at the University of California, Irvine, has demonstrated through decades of research that false memories can be implanted with surprising ease. Subjects can be convinced that they experienced events that never happened, and these false memories feel just as real and emotionally compelling as genuine recollections. The ease with which memory can be manipulated reveals that temporal experience is far more malleable than we normally recognize. If our sense of personal past can be altered through suggestion or imagination, then the temporal continuity that defines personal identity may be much more fragile than we assume. Research into prospective memory, our ability to remember to perform actions in the future, reveals similar constructive processes. Rather than simply storing information about future intentions, the brain creates complex neural models that simulate future scenarios and embed reminder cues in anticipated contexts. These future-oriented mental constructions shape present behavior and decision-making in ways that create the appearance of temporal causality from future to past. The neuroscience of temporal perception also reveals striking individual differences in how time is experienced. Some people naturally experience time as passing quickly, while others experience it as moving slowly. These differences correlate with variations in brain structure and function, suggesting that the rate of subjective temporal flow is determined by individual neural characteristics, rather than objective temporal properties. Children experience time differently than adults, with young children showing limited ability to understand temporal concepts like yesterday or next week. The development of temporal cognition appears to be a learned skill that emerges gradually as the brain's temporal processing networks mature. This developmental progression suggests that sophisticated temporal experience is a cultural and cognitive achievement rather than a basic feature of consciousness. Cultural differences in temporal perception provide additional evidence that time experience is constructed rather than universal. Different cultures organize temporal experience in fundamentally different ways, with some emphasizing cyclical time, others focusing on linear progression, and still others treating past and future as equally present and accessible. Indigenous cultures often describe temporal experience in ways that more closely match the timeless reality revealed by physics than the linear time emphasized in Western cultures. Aboriginal Australian concepts of dreamtime describe a realm where past, present and future coexist simultaneously. Many Native American traditions describe time as circular rather than linear, with past and future events equally accessible through proper spiritual practices. These cultural variations in temporal experience suggest that the linear, flowing time that seems so natural to modern Western consciousness may be a culturally specific construction rather than a universal feature of human awareness. Other forms of temporal experience, cyclical, multi-directional or timeless, may be equally valid ways of organizing conscious experience. The neuroscience of dreams provides additional insights into consciousness without normal temporal constraints. During REM sleep, the brain's normal temporal binding mechanisms are disrupted, allowing dream consciousness to experience events in non-linear sequences, to access memories from different time periods simultaneously, and to create elaborate narratives that violate ordinary causal relationships. Dream research reveals that consciousness can function coherently without the temporal constructions that organize waking experience. Dream logic operates according to associative and symbolic principles rather than temporal sequence, yet dream experiences feel meaningful and emotionally compelling despite their temporal incoherence. These findings from neuroscience, psychology, and consciousness research converge on a revolutionary conclusion. The experience of flowing time is not a perception of objective temporal reality, but a sophisticated construction created by specific neural networks in the brain. When these networks are disrupted through injury, altered by psychedelic compounds, suspended through meditation, or bypassed during dreams, consciousness reveals its capacity to function in fundamentally non-temporal ways. This recognition transforms our understanding of what consciousness actually is. Rather than being a stream of experiences flowing through time, consciousness may be better understood as a timeless field of awareness that creates the illusion of temporal flow through specific information processing strategies. From this perspective, the hard problem of consciousness, the question of how subjective experience arises from objective physical processes, may be based on a fundamental misconception. If consciousness is timeless while physical processes appear to occur in time, then consciousness cannot be produced by physical processes. Instead, consciousness may be the more fundamental reality from which the appearance of physical processes and temporal flow emerges. But to understand the full implications of recognizing consciousness as timeless awareness that creates temporal experience, we must explore what this means for human identity, free will, death, and the possibility of finding meaning in a reality where time itself may be nothing more than a persistent and convincing illusion. In the philosophy department at New York University, philosopher of mind Thomas Nagel sits in his office, surrounded by centuries of philosophical treatises that grapple with humanity's deepest questions about existence, identity, and moral responsibility. But the equations covering his whiteboard come not from philosophy but from physics. Einstein's field equations, the Wheeler-DeWitt equation, the mathematical structures that describe a universe where time does not fundamentally exist. Nagel is wrestling with a problem that bridges science and philosophy. If time is indeed illusory, what happens to everything we believe about human nature, free will, and the meaning of existence itself? The implications are staggering and touch every aspect of human self-understanding. If we exist in a timeless block universe where all moments are equally real and eternal, then death is not the cessation of existence but merely a boundary in four-dimensional space-time. Your birth, your current reading of these words, and your eventual death all exist simultaneously in the unchanging structure of reality. From this perspective, you're not a temporary pattern of matter and energy that briefly flickers into existence before dissolving back into nothingness, but an eternal feature of the timeless landscape of being. This recognition transforms the very meaning of mortality. Death becomes not an ending but a limitation, like the edge of a painting or the final page of a book. The moments of your life that you remember as past and anticipate as future exist with the same ontological status as your present experience. Your childhood, your first love, your greatest achievements, and your final breath all possess equal reality in the four-dimensional block of space-time. But if death is not truly an ending, what does survival mean? Personal identity, as traditionally understood, depends on continuity through time, the sense that the person who was born decades ago, who is reading these words now, and who will die in the future are all the same individual. Yet if time is illusory, then this temporal continuity cannot be the basis of personal identity. Instead, identity in a timeless universe might be better understood as a pattern or structure that exists across the spatial dimensions of space-time rather than through temporal duration. You're not a stream of consciousness flowing through time, but a four-dimensional object extended through space-time, with your birth and death marking the boundaries of your existence, just as your physical form marks the boundaries of your spatial extension. This block universe conception of personal identity has profound implications for how we understand memory, anticipation, and planning. Memory does not connect you to past events that no longer exist, but allows you to access information from other regions of your timeless existence. Similarly, anticipation and planning do not prepare you for a future that has not yet arrived, but represent your capacity to navigate the four-dimensional landscape of your eternal existence. Free will presents even more challenging paradoxes in a timeless reality. If your future actions already exist in the block universe, with the same ontological status as your past experiences, are your choices predetermined? The question becomes particularly acute when we consider that from the block universe perspective, your decision to read these words, your emotional response to these ideas, and every choice you will make for the rest of your life already exist as eternal features of space-time. But this apparent determinism may be based on a misunderstanding of how causality operates in timeless reality. Traditional concepts of determinism assume that past events cause future events through temporal processes. If time is illusory, then causality cannot operate through temporal succession, but must be understood as relationships between events that exist simultaneously in four-dimensional space-time. Philosopher Tim Maudlin at Rutgers University has argued that free will in a block universe should be understood not as the ability to change the future, but as the capacity to participate in determining which four-dimensional structure actually exists. Your choices do not alter a predetermined timeline, but contribute to defining the specific configuration of events that constitutes reality itself. This participatory view of free will suggests that conscious beings are not passive observers of a predetermined block universe, but active participants in determining its structure. The decisions you make, the actions you take, and the intentions you form all contribute to specifying which of the infinitely many possible four-dimensional realities actually exists. The implications extend to moral responsibility and ethical behavior. If your actions are eternal features of space-time rather than temporary events, then their moral significance may be even greater than traditionally understood. Harmful actions do not disappear into the past but remain as permanent features of the block universe. Acts of kindness, courage, and compassion similarly exist eternally as positive contributions to the structure of reality itself. Buddhism and other contemplative traditions have long recognized the timeless nature of moral action. The concept of karma suggests that actions have consequences that extend beyond the temporal boundaries of individual life, creating patterns that persist across what appear to be different times and contexts. If reality is indeed timeless, then karma might be better understood as the way that conscious actions shape the eternal structure of existence, rather than causing future events through temporal processes. The recognition that all moments exist eternally also transforms our understanding of suffering and happiness. Pain and joy do not pass away with time, but exist as permanent features of conscious experience within the block universe. This might initially seem to make suffering more terrible. If painful moments never truly end, how can we find comfort in the thought that this too shall pass? But timeless existence also means that moments of joy, love, and transcendence are equally eternal. Every instant of happiness, every experience of beauty, every moment of connection with others exists forever as an unchanging feature of reality. The block universe preserves not just suffering, but all the positive aspects of conscious existence in eternal form. This eternal preservation of all experiences suggests a different approach to dealing with suffering. Rather than waiting for painful experiences to pass, we might learn to recognize them as temporary constructions of temporal consciousness that are balanced by equally real moments of joy and transcendence elsewhere in our four-dimensional existence. Indigenous cultures that recognize the illusory nature of linear time developed sophisticated approaches to living in harmony with timeless reality. Many Native American traditions speak of the eternal now, where all times exist simultaneously and where ancestors and descendants are equally present and accessible. The Lakota concept of Mitakuye Oyasin, all my relations, reflects an understanding that individual existence is inseparable from the timeless web of relationships that connects all beings across what appear to be different times. Australian Aboriginal concepts of dreamtime describe a realm where the creative activities that shape the landscape continue to exist as eternal present realities. Past and future are not separate from the present, but are accessible through proper spiritual practices and ritual engagement. The Dreamtime stories that encode practical knowledge about navigation, ecology, and social relationships operate outside linear temporal frameworks. These traditional understandings of timeless reality often included practices for accessing non-ordinary states of consciousness, where linear time perception dissolves. Shamanic journeying, vision quests, ceremonial plant medicine, and various forms of meditation allow practitioners to experience the simultaneous existence of past, present, and future that physics suggests is the true nature of reality. Modern research into these traditional practices is revealing their potential for helping people adapt to the implications of timeless existence. Studies of ayahuasca ceremonies, guided by indigenous shamans, show that participants often report profound shifts in their understanding of time, death, and personal identity. Many describe experiencing their entire life simultaneously, gaining insights into the interconnected nature of all their experiences across what they previously understood as different time periods. Psychedelic research in clinical settings is revealing similar therapeutic benefits from experiences of timeless consciousness. Patients with terminal cancer who receive psilocybin therapy often report dramatic reductions in death anxiety after experiencing states of consciousness where they perceive their existence as extending beyond the temporal boundaries of biological life. These therapeutic applications suggest practical approaches to living with the recognition that time is illusory. Rather than causing nihilistic despair or paralyzing confusion, understanding the timeless nature of reality might enable more authentic and fulfilling ways of existing. If your entire life exists eternally within the block universe, then every moment carries ultimate significance. There are no throwaway experiences or meaningless interactions, because everything you do contributes to the permanent structure of your four-dimensional existence. This recognition might inspire greater attention to the present moment, not because it is fleeting and will soon be lost, but because it is eternal and will always remain as part of who you are. The block universe perspective also suggests different approaches to planning and decision-making. Rather than trying to control future events that have not yet occurred, You might learn to navigate the landscape of your timeless existence with greater wisdom and intentionality. Planning becomes not manipulation of temporal sequences, but conscious participation in defining the structure of your eternal existence. Relationships with others also take on deeper significance in timeless reality. Every interaction you have with another person creates permanent features in the four-dimensional structure of both your existences. Expressions of love, moments of understanding, and acts of mutual support become eternal aspects of your shared reality, rather than temporary exchanges that fade with time. Even conflicts and misunderstandings gain different meaning when understood as permanent features of timeless existence. Rather than events that can be forgotten or left in the past, they become opportunities for learning and growth that exist eternally as part of the total structure of relationship between conscious beings. The recognition of timeless existence might also transform approaches to learning and personal development. Knowledge and wisdom are not acquired through temporal processes, but represent ways of accessing information that already exists within the structure of reality. Education becomes not the accumulation of information over time, but the development of capacities to navigate and understand the timeless landscape of existence. Creativity and artistic expression gain new significance as ways of participating in the eternal creation of reality's structure. Every poem written, every song composed, every painting created contributes permanently to the four-dimensional architecture of existence. Artists are not creating temporary cultural artifacts, but participating in the ongoing specification of reality's eternal form. The implications for scientific research and philosophical inquiry are equally profound. If time is illusory, then the project of understanding reality must be reconceived as exploration of timeless structures rather than investigation of temporal processes. Science becomes not the study of how things change over time, but the mapping of eternal relationships that exist simultaneously in four-dimensional space-time. But perhaps the most profound implication of recognizing timeless reality is that it dissolves the fundamental anxiety that drives much of human behavior, the fear that existence is temporary and meaning is fragile. If you exist eternally within the structure of a timeless reality, then your existence has ultimate security and permanent significance. This security is not based on personal survival after death or on the persistence of individual consciousness through time, but on the recognition that consciousness and existence themselves transcend temporal boundaries. You're not a temporary configuration of matter and energy that briefly exists before disappearing, but an eternal participant in the timeless structure of being itself. The question is whether humanity can learn to live with this recognition, integrating the insights from physics about time's illusory nature with practical approaches to existence that honor both our temporal experience and our timeless reality. The synthesis of scientific understanding and conscious living may represent the next stage in human development, learning to exist consciously within the eternal now, while continuing to function effectively within the constructed temporal framework that organizes daily life. In the meditation hall of the Mindfulness Research Institute at Brown University, neuroscientist Judson Brewer sits in silent contemplation, his brain connected to the most advanced neuroimaging equipment available to science. On monitors in the adjacent control room, researchers watch in real time as the neural networks that normally construct temporal experience gradually dissolve into stillness. The default mode network that creates narrative continuity shuts down. The temporal binding mechanisms that organize experience into sequential moments fade into silence. What remains is pure awareness, consciousness without temporal content, existing in what ancient contemplatives called the eternal now. This convergence of cutting-edge neuroscience and millennia-old contemplative wisdom represents humanity's growing recognition of a truth so fundamental that it challenges every assumption we have made about the nature of existence. Time, as we experience it, is not real. The flowing sequence of moments from past through present to future that seems so basic to human consciousness is revealed by physics, neuroscience, and direct contemplative experience to be a persistent and convincing illusion. The evidence assembled throughout this investigation points inexorably toward the same conclusion. Einstein's relativity theory demolished absolute time and revealed the block universe where past, present, and future exist simultaneously. Quantum mechanics operates in a fundamentally timeless realm, where events are connected by relationships that transcend temporal sequence, thermodynamics shows that time's arrow emerges from statistical asymmetries rather than fundamental temporal flow. Neuroscience reveals that temporal experience is actively constructed by specific brain networks that can be disrupted or suspended. Consciousness research demonstrates that awareness can access timeless states where linear time perception completely dissolves. Each line of evidence, pursued independently by researchers across different disciplines, converges on the same revolutionary recognition. The reality we inhabit is fundamentally timeless, and the experience of temporal flow is a construction of consciousness rather than a feature of the external world. This recognition represents one of the most profound shifts in human understanding, since Copernicus revealed that Earth is not the center of the universe. Just as astronomy forced us to recognize that our physical location is not privileged in cosmic terms, the discovery of time's illusory nature forces us to recognize that our temporal experience is not a reliable guide to the fundamental nature of reality. But unlike previous scientific revolutions that displaced humanity from positions of cosmic significance, the recognition of timeless reality may actually restore meaning and importance to human existence in unexpected ways. If time is illusory, then consciousness, which creates temporal experience from timeless reality, assumes a far more central role in the structure of existence than previously imagined. From the timeless perspective revealed by physics, consciousness is not a temporary emergence from complex arrangements of matter and energy, but may be the fundamental feature of reality that gives rise to the appearance of matter, energy, space, and time themselves. Rather than being produced by physical processes occurring in time, consciousness may be the timeless substrate from which the entire phenomenal world emerges. This possibility transforms our understanding of what it means to be conscious. Instead of being fleeting patterns of neural activity that briefly exist before dissolving back into unconsciousness, we may be eternal aspects of a timeless awareness that temporarily experiences itself as existing within constructed temporal frameworks. The mystical traditions of virtually every culture have preserved this understanding across millennia. Hindu philosophy describes Brahman, the ultimate reality underlying all apparent diversity, as Sat Chit Ananda, pure existence, pure consciousness, and pure bliss that exists beyond the temporal cycles of creation and destruction. Buddhist teachings speak of Buddha nature as the deathless, birthless awareness that underlies all temporary manifestations of consciousness. Christian mystics like Meister Eckhart describe the eternal now, where past and future collapse into pure presence. Islamic Sufis speak of Fana, the dissolution of temporal selfhood into timeless divine consciousness. Jewish Kabbalah describes the Ein Sof, the infinite reality that exists beyond all temporal limitations and conceptual boundaries. These contemplative traditions developed sophisticated practices for accessing the timeless awareness that physics now suggests is the fundamental nature of consciousness itself. Meditation, prayer, contemplative inquiry, and various forms of spiritual practice represent technologies for suspending the brain's temporal construction mechanisms and accessing direct experience of timeless reality. The scientific validation of these contemplative insights suggests that the division between spiritual and scientific understanding may be based on a false dichotomy. The deepest insights of physics and the highest realizations of contemplative practice point toward the same truth. Reality is fundamentally timeless, and the experience of temporal flow is a construction of consciousness rather than an objective feature of existence. This convergence of scientific and contemplative understanding opens extraordinary possibilities for human development and flourishing. If consciousness can learn to operate from timeless awareness, while continuing to function effectively within temporal constructions, we might develop capacities for wisdom, compassion, and creative expression that far exceed what seems possible from purely temporal perspectives. The implications for addressing humanity's deepest challenges are profound. Many of the problems that seem intractable from temporal perspectives, death anxiety, meaninglessness, interpersonal conflict, environmental destruction, may be rooted in the illusion of temporal separateness that creates the sense of isolated individual existence competing for scarce resources within limited timeframes. From timeless awareness, these problems appear in entirely different contexts. Death anxiety dissolves when consciousness recognizes its eternal nature. Meaninglessness disappears when every moment is recognized as eternally significant. Interpersonal conflict diminishes when others are experienced as aspects of the same timeless awareness, rather than separate entities competing across time. Environmental destruction becomes impossible when the eternal interconnectedness of all existence is directly experienced rather than merely intellectually understood. The recognition of timeless reality also suggests radically different approaches to education, healthcare, governance, and economic organization. Educational systems might focus on developing capacities for accessing timeless awareness rather than accumulating temporal information. Healthcare might emphasize practices that align with the timeless nature of consciousness, rather than merely maintaining temporal biological processes. Governance structures might be designed to honor the eternal significance of all choices rather than maximizing short-term temporal outcomes. Economic systems might be reorganized around principles of timeless abundance rather than temporal scarcity, recognizing that consciousness and creativity, the sources of all genuine value, are unlimited resources that exist outside temporal constraints. But perhaps the most important implication of recognizing time's illusory nature is that it resolves the fundamental existential anxiety that has haunted human consciousness throughout history, the fear that existence is temporary, fragile, and ultimately meaningless. If you exist eternally within the structure of a timeless reality, then your existence has ultimate security and permanent significance that cannot be threatened by any temporal change or loss. This security is not based on personal survival after death, or on the persistence of individual identity through time, but on the recognition that consciousness itself transcends temporal boundaries. You're not a temporary pattern that briefly exists before dissolving back into nothingness, but an eternal expression of the timeless awareness that constitutes the deepest reality of existence. The question that remains is whether humanity can integrate this recognition into practical approaches to living that honor both our temporal experience and our timeless nature. The challenge is not to abandon the temporal constructions that organize daily life. These serve essential functions for navigating the physical world, but to recognize their constructed character while operating from the deeper understanding of timeless reality. This integration might be understood as a form of conscious bilingualism, maintaining fluency in the temporal language necessary for practical functioning while remaining grounded in the timeless awareness that is consciousness itself. Just as bilingual individuals can switch between different languages depending on context while maintaining a unified sense of identity, conscious beings might learn to switch between temporal and timeless modes of awareness depending on what each situation requires. The development of this capacity for conscious bilingualism between temporal and timeless modes of awareness may represent the next stage in human evolution, not biological evolution occurring through temporal processes, but consciousness evolution occurring through the expansion of awareness into its own timeless nature. This evolution is already beginning to manifest through the convergence of scientific research and contemplative practice that is revealing time's illusory nature. As more individuals access direct experience of timeless awareness, while maintaining effective functioning within temporal constructions, humanity may develop collective capacities for wisdom and compassion that seemed impossible from purely temporal perspectives. The ultimate implication of recognizing that time is not real is that reality itself is far more magnificent and meaningful than we ever dared imagine. Rather than being temporary accidents in a universe heading toward inevitable heat death, we are eternal expressions of timeless consciousness, exploring the infinite possibilities of existence. Every moment of experience, from the most mundane daily activities to the most profound insights and connections, contributes permanently to the structure of eternal reality. Nothing is ever lost because nothing ever was temporary. Everything exists forever within the timeless landscape of being. The anxiety and meaninglessness that characterize so much of modern existence dissolve when consciousness recognizes its eternal nature. The competitive struggles that create so much suffering become unnecessary when abundance and significance are understood as inherent features of timeless reality, rather than scarce resources that must be acquired through temporal processes. The fear of death transforms into curiosity about the nature of consciousness beyond temporal boundaries. The search for meaning becomes a celebration of the eternal significance that every moment already possesses. The effort to achieve happiness becomes a recognition of the joy that is inherent in timeless awareness itself. But this transformation is not automatic or inevitable. It requires the conscious recognition of time's illusory nature and the deliberate cultivation of awareness that can function from timeless understanding. The scientific evidence for time's unreality provides the intellectual foundation for this recognition, but direct experience of timeless consciousness is necessary to make the understanding transformative rather than merely conceptual. The contemplative practices developed over millennia by wisdom traditions around the world provide proven methods for accessing this direct experience. Modern neuroscience is beginning to understand how these practices work and how they might be integrated with contemporary approaches to human development and flourishing. The synthesis of scientific understanding and contemplative practice may represent humanity's greatest opportunity for conscious evolution. Not evolution through temporal processes of random mutation and natural selection, but conscious participation in the eternal unfolding of awareness into ever greater expressions of wisdom, compassion, and creative possibility. The recognition that time is not real does not diminish human existence but reveals its true grandeur. We are not temporary visitors in an alien universe, but eternal expressions of the consciousness that is the deepest reality of existence itself. Every choice we make, every relationship we form, every moment of awareness we experience contributes permanently to the structure of timeless reality. The question is no longer whether time is real. The evidence from physics, neuroscience, and consciousness research has answered that question definitively. Time as we experience it is not real. The question now is whether we will learn to live from this understanding, allowing the recognition of our timeless nature to transform how we exist, how we relate to others, and how we participate in the ongoing creation of reality itself. The answer to this question will determine not whether consciousness survives — consciousness is eternal and cannot be threatened — but what kind of eternal reality we choose to create through our conscious participation in the timeless, now that is the only time there has ever been or ever will be. We are the universe becoming conscious of its own timeless nature. The question is, what will we do with this recognition?